All right, this video covers the Chapter 3 practice exam. First question, which one of these shows a perpendicular bisector? Perpendicular bisector is a line that intersects with another line at 90 degrees, and it cuts that original line into two equal parts. So the one that does that would be this one here. So perpendicular, 90 degrees. And then it's cutting this one exactly, this line segment exactly in half, and that is shown by these two hash marks. This one's a perpendicular line, but doesn't cut, that line doesn't cut this into equal parts. Parallel lines, intersecting lines, so A. Which following shows an angle bisector? Okay, so an angle bisector takes an angle and cuts it into two new equal angles. And we're looking for an angle being cut in half. Now, here we have an angle being cut in half. So we see this one, and we can even measure it if we want. But the way this one stands out is we see these two circles right here that signal their labeling of the angle bisector as those two angles are equal. So this one is at about a 72. Okay, so here we are at 72 and about a 38, so we're right. 72, yeah, somewhere in there. Okay, so that one is D. Next page. Okay, so using these, which line segments are parallel? So we're looking for our parallel lines is these arrows in the middle, and then also the distance between them is the same, is unchanging, meaning that these lines, if these segments went on forever, they would never touch. That's the difference here. These two are getting closer together. If they continued on, they would touch further apart. Those intersect, so they can't be parallel. These also intersect, they're not parallel. So then that would be B, which is perpendicular. So perpendicular again means meeting at 90 degrees. There's only one here meeting at 90 degrees, and that's shown by this 90 degree box right there. So that would be C. An angle bisector is a line segment, so we already talked about this, but an angle bisector takes the original angle and cuts it exactly in half. Line segment that divides an angle into two equal parts. It's true. Another line segment in half, no. Another line segment in half, no. Forms an angle of 90 degrees, so another line segment, no, that's perpendicular. So A, perpendicular line segment, as I said up here, intersects at 90 degrees. So we got to find one that says intersects at 90 degrees. Forms a 90 degree angle with another line segment. So it's D. Okay, divides another line segment in half and forms a 90 degrees, so that's a perpendicular bisector. Divides another line segment in half, that's just a bisector. And divides another angle into two equal parts, or an angle bisector. Perpendicular bisector, okay, is a line segment that, so this one has to intersect at 90 degrees and also cut the original line in exactly half. Divides another line segment in half and forms 90 degrees, so B. All right, so now we're gonna start finding the area of these. So a reminder for this one is a triangle. Base of acute triangle is 10 centimeters, height's 14, what's the area? So the formula, area equals base times height divided by 2. Okay, this one says the base is 10 times 14 divided by 2. 10 times 14 is 140. Divided by 2 is going to be 70 centimeters squared. So it's C. Okay. The next one, parallelogram, area equals base times height. So our base along the bottom, area equals 8 centimeters. And then our height is recorded by measuring perpendicular to the base. So this is a side measurement, we don't care about that. Perpendicular times 5. So the area of this one is 40 centimeters squared, which is C. Okay, next one was the area of a parallelogram with side length. So another area of parallelogram, area equals base times height. Side length, we don't care about side length. A base of 1.4. and then a height of 2.4. Okay, so we're going to multiply 1.4 times 2.4. I'm being lazy, I'm gonna find a calculator. 1.4 times 2.4. 3.36, so here we are. 3.36b meters squared. Forgot that part. Area of a triangle. Area equals base times height divided by 2. Okay, so our base, 12 centimeters by 9 centimeters divided by 2. Area equals 12 times 9 is 108. Divided by 2 is going to be 54 centimeters squared. So that is A. Okay. Next, Kent wants to cover his parallelogram shaped backyard with turf. Parallelogram has a base of 16 and a height of 10 meters. If the turf costs $5 per meter, how much will Kent spend? So first, let's find the area. Parallelogram, so base times height. Area is 16 meters by 10 meters. So that's going to give us 160 meters squared. Now it says $5 per meter. So then I just take that 160 and times that by the $5. Is going to equal, I think I know the answer, I'm just going to double check. I think it's 800. 800 it is. $800. So that's D. 11. Find the area of a triangle with a base of 7, height of 8, side length of 9. Again, if you don't care about that, cross it off. Area equals base times height divided by 2. Area equals 7 times 8 divided by 2. 7 times 8 is 56. Divide 56 in half and you get 28 centimeters squared. That's an 8. So that's A. An unknown angle is bisected. One of the resulting angles is then bisected again. If the measure of the angles resulting from the second bisection is 17, what's the original angle? Okay, best thing to do on something like this is to draw a picture. So I have an angle. Doesn't matter what I draw, just it's an angle. So then it's bisected. So bisected means it's cut in half. Okay, so this is equal to this. If one of the resulting angles is bisected again, so now I'm going to bisect this one. If the measure of the angles resulting are 17 degrees, so this is 17, 17. What's the measure of the original? Okay, so remember, those two together is half. So those two together, 17 and 17 is 34. So there's 34 in this half, and there's 34 in this half. So what's that total? 68. Original angle was 68 degrees, cut it in half, made two 34s, cut a 34 in half, gave you two 17s, right there. The two new angles created by drawing an angle bisector. So we made an angle bisector. What are the two new angles that were connected? They're equal, greater than 90. No, these ones are 34. Less than 90, well, those ones were, but this obtuse angle is going to be greater than 90. Equal to 90, no, so it's equal. So no matter what the original angle is, once I bisect it, then two new angles are equal. When an angle bisector is drawn, the two new angles is basically the exact same question. A parallelogram and triangle have the same base and the same height measurements. What do you know about the area of these two shapes? Okay, area, triangle, say it's 10 and 10, and a parallelogram is 10 and 10. This one's going to be 100 base times height. This is going to be base times height divided by 2. This one's going to be 50. So this triangle is exactly half of this. The area of the triangle is half the area of the parallelogram, A. Formula for this, area equals base times height divided by 2. Area, okay, these should have been at the first, I guess, right? Base times height. Okay, draw a line is it perpendicular to this line. Here's a sharpen my pencil here real quick. Draw a line that is perpendicular to this line. Okay, again, perpendicular means 90 degrees. So there's two ways you can do it. It just says perpendicular, so it doesn't have to be in the middle, it doesn't have to be anything. So I'm gonna put a mark there to start. Okay, I can set up my compass. Not a compass, come on, man. Protractor. Mark it at 90. Draw that line, get on there and on there, draw a line there. Okay, so that's at 90 degrees, that's why I label that as perpendicular. Now, remember the other way. So here's our line. If I just want to draw one, and we'll probably do this at some other point, but remember just over half. And I can put my mark at the top, put my mark down at the bottom, switch ends. This one's going to give us a bisector, of course, but it still gives us a perpendicular line. Okay, and I go from this one down to the opposite, and there we go, 90 degrees. Draw an angle bisector in this angle. Again, the two methods: throw on your protractor, measure it, cut that in half. Okay, so it says it's 70, so it's going to be at 35. Mark that there. Now we'll also show the second one. So remember, on an angle bisector, so you go with the vertex without changing your thing, put a mark there and a mark there. Now use those two new marks and draw an arc out in the middle. Switch to the opposite, draw another mark in the middle. Now I've got an X there and my vertex. I line those up and it's going to line up perfectly with this. Dun, dun, dun. There we go. It's now bisected. How do I label it as an angle bisector? Put these two circles in there. Boom. So this was 35 degrees. That was 35 degrees. Two new equal angles. Okay, what's the area of the triangle shown below? Again, area equals base times height divided by 2. Area equals 14.7 times 12.9 divided by 2. Don't know that one off the top of my head. 14.7 times 12.9 equals, divided by 2, 94.815 centimeters squared. All right, a couple more questions here. Draw a 64-degree angle, label the angle ABC. Now bisect that label. Okay, now I'm just going to do this all in one. So 64 degrees, and I'm going to bisect it. So what's half of 64? 32 degrees. So I'm just going to label that while I'm doing this. So here we go. We're going to put this out there. There's my vertex. So I want to draw 64. Okay, 64 is right there. And then my bisected angle is 32. So 32 is right there. Okay, so now I'm going to draw this line out. So that's now my 64 degrees. And then here's my bisector. So I come here and draw that one a little shorter. Take that. Okay, now I'm going to mark that those are equal, labeled correctly. Draw a line 14 centimeters. There's a ruler, 14 centimeters. So there's my dot to start. 14 goes to right there. EF. Okay, now draw a perpendicular bisector of EF and label a bisector G. So it's going to be stop there. Include all necessary labels. Okay, so as my line. So again, I could have done that when I started. So I could do this without the compass. Half of 14 is 7. So it's going to end there. I'm just going to put that there because I already cut it in half. Use my protractor, place it on my center mark and down on my line. Mark it at 90 because I need it to be perpendicular. Come straight down. I was going to end right there and I went a little past. I got all excited about what was happening. And this one's labeled G, I believe it says. And then the last thing I got to do is put that 90-degree box there. Okay. Hash marks for being bisector. So this one's 7, this one's 7. Okay, last one. Veronica created a logo. Nice, V. You notice that's a parallelogram, so is that one, right? Parallelogram. If she plans to sew the Lego on a banner, how much material would she need? So we're going to find the area of these two. Okay, so this is 8 total. So we're just going to do one of them. Now, there's a couple ways you can do this, but so if it's half of that, so this is 4 centimeters. This is 4 centimeters. And then our height, remember our height is parallel from this line to this line, 40 centimeters. Area equals base times height. Area equals 4 by 40. Area equals 4 times 40 is 160 centimeters squared. Now there's 2 identical ones, so you just times that by 2. Okay, so area is 320 centimeters squared is how much material she needs. And I believe that's the end of it. All right, there's the practice test.